Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. So, before going to the today's class, we have discussed in our previous class about rational numbers, right? So, what are the rational numbers and how can we identify the rational numbers between them and decimal form of a rational numbers? What is the decimal form of a rational number? Yeah. It is either terminating decimal or non-terminating repeating decimal. What is the decimal form? Terminating rational numbers, either terminating or non-terminating repeating. Non-terminating repeating decimals, and we have discussed some examples on it, and that too we need to discuss one more point. If A and B are any two rational numbers, A and B are any two rational numbers, the rational number exactly between A and B is A plus B by 2. The rational number between A and B is A plus B by 2. Or to find more than one rational number between them, because between any two numbers we can insert infinite number of rational numbers. Between any two numbers we can insert infinite number of rational numbers. Am I right? In same way, the between rational numbers from A and B are in the form of A plus D, A plus 2D, A plus 3D, we have discussed like this, and so on. How many you want, that many we can write like this. And what is D? D is the common difference, that equals to B minus A by N plus 1. Here the condition is B value is more than A. Then larger number minus smaller. B minus A by N plus 1, where A is number of rationals. So if you want 9 rational numbers, B minus A by 9 plus 1. Okay, that is the value of D. Then that difference we can add to A continuously up to how many you want, that many will get. Okay, no? So this is about the rational numbers. Now, while you are observing here, the rational numbers, either the form of terminating or non-terminating repeating. Non-terminating repeating decimals are there. If there are non-terminating non-repeating decimals also there. Non-terminating non-repeating decimals also there. Such type of numbers are called irrational numbers. Such type of numbers are called irrational numbers. What are the irrational numbers? Non-terminating, non-repeating decimals. Let me write one example here. For example, 1.636363 and so on. While you are observing that the decimal values or decimal numbers 6 and 3 are repeating continuously like this, 1.63 bar, we can express like this. That means the period 63 is repeating continuously, and so on indicates it is never ending decimal. It is continuously like that. So non-terminating repeating, this is the example for rational numbers. But irrational numbers, non-terminating, non-repeating means these are rationals. Non-terminating, non-repeating means like 1.6315439 and so on like this. There is no such period is repeating like 63, 63, 63, 63, 63 like this. Here we did not identify any such period repeating in this decimal form. This type of numbers are called irrational numbers. Okay, na? So simply the decimal form of a irrational number is non-terminating, non-repeating. non-terminating, non-repeating. So as we learned that rational numbers are in the form of P by Q. The numbers we can written in the form of P by Q are called rationals. Such a way, the numbers which are cannot be written. What is irrational numbers? The numbers cannot be written in the form of P by Q are called irrational numbers. Cannot be written in the form of P by Q. Such type of numbers are called irrational numbers. What are the examples for this? So irrational numbers are mainly three different types are there. One is decimal form, nothing but non-terminating, non-repeating decimals. And second one is in the form of root 2, root 3, root 5, root 6, root 7 and so on like this. These are also called irrational numbers because these are not able to write in the form of P by Q. Sir, can we write root 2 as root 2 by 1? No, sir. We can write root 2 as root 2 by 1. Then it is in the form of P by Q, right? It is in the form of P by Q. Then can we call that rational numbers? No. Why? In the condition of P by Q, P comma Q belongs to integers. That means P value, Q value must be integers. Okay? P and Q are integers. But root 2 is not an integer. Root 2 is not an integer. So here root 2 is called irrational number. So according to the actual definition, if m is a positive number, m is a positive integer, if m is a positive integer, it cannot be, that means root m is a irrational number if m is not a perfect square. Root m is irrational only m is not a perfect square. Okay, na? If you are at cube root m, here square root, this is square root. Square root is nothing but, if you write the square root in the form of exponents, we have to write like this, m power 1 by 2, square root. Exponential form of square root is 1 by 2 and cube root exponential form 1 by 3. Such a way here, to tell root m is irrational number, m should not be perfect square. Same way cube root m is irrational, only possible m is not a perfect cube. Okay, na? This is one type of irrational numbers. First one is non-terminating, non-repeating decimals. This is root over, cube root over, fourth root, fifth root, like that. Cube root, fourth root, fifth root. Okay, na? Such type of numbers where m cannot be perfect square, m cannot be perfect cube, m cannot be power of 4, m cannot be power of 5. Such type of numbers are called irrational numbers. Clear? And third one, the value of pi and e. These are called transcendental irrational numbers. Transcendental irrational numbers. You know that pi value 3.14. Sir, 3.14 is terminating decimal, but you have discussed that pi value irrational number, we are saying that, but irrational numbers are non-terminating, non-repeating, but here 3.14 is a terminating decimal. It is stopped up to 3.14, but it is just approximate value, not exact value. Exact value of pi 3 point, until then 200, 250 decimal numbers will be find out. Okay, na? So pi and e, eccentricity. Okay, na? So this is 2.718. this value, approximate value, not exact value. These two are also called irrational numbers. Okay, na? Pi and e values are irrational numbers. Such a way, third type, and first one is non-terminating, non-repeating, and second one is root form. So three different type of irrational numbers we found. Clear? Yes. So let us see this. Properties of irrational numbers, very, very important properties of irrationals. So mainly, before discussing about the properties, let us see this. If you take any rational number, A is any rational number, root B is irrational number. If you take one rational number and one irrational number, if you apply the arithmetical operations between them, what are the arithmetical operations? Plus, minus, into, and division. If you apply any one of the arithmetical operation, then the result will be irrational number. Result will be irrational number. Okay, let us go to the properties of irrationals. First property, sum of any two irrationals. If you take two irrational numbers, sum of any two irrationals need not be irrational. Okay, na? Sum of any two irrationals are need not be irrational number. Clear? That means 5 plus root 3 is irrational number, right? 5 plus root 3 is irrational number. Just now I discussed about if you take one rational number and one irrational number, between them, if you apply any one of the arithmetical operation, any arithmetical operation you apply, the result will be irrational always. Here 5 is a rational number, root 3 is irrational number, and their sum will be irrational. And the two irrational numbers are represented with the letter Q dash. Rational numbers are represented with Q. Irrational numbers are represented with Q dash. Okay, na? Yeah. So, what is the first condition I have given? Sum of any two irrational numbers need not be irrational. Now, so I have taken that 5 plus root 3 is one of the irrational number. Need not be irrational. Yeah. Five plus root 3 is a irrational number. 5 minus root 3 is also a irrational number. Now, first irrational number is 5 plus root 3. Second irrational number is 5 minus root 3. According to the condition, sum of two irrationals, sum means addition. While I am adding both of them, plus root 3 minus root 3 cancel. 5 plus 5 becomes 10. So, sum of two irrationals need not be irrational. That means in some cases it can be a rational number. Because you are adding two irrational number, answer need not be always irrational. Need not be always irrational. Some situations it can be rational also. Like this example. Same way, second one, product of two irrationals. Product of two irrationals, same, need not be irrational. Need not be irrational. Same example I am taking, 5 plus root 3 into 5 minus root 3. When you multiply, it is in the form of a plus b into a minus b. Am I right? Just compare here. A value 5, b value root 3. A value 5, b value root 3. A plus b into a minus b, algebraic identity. A square minus b square. Now let us see here. A value 5, 5 square minus b value is root 3. Root 3 whole square. 5 square, 5 5 is 25. Root 3 whole square means 3. 24 minus 3, 22. Okay, no? So 22 is a rational number. So from this we have to decide that product of two irrational numbers need not be rational. Okay, that is depends on the irrational numbers we have taken. Okay, no? Clear? Yeah, maximum they can be irrational numbers if they did not follow such type of identities like this. Clear? Sum of two irrationals need not be irrational. Product of two irrationals also need not be irrational. And irrational numbers are represented with the letter Q dash. Okay, na? Yeah. Now, write that if A is a rational, if A is a rational number and root B is irrational, A is a rational number, root B is irrational number. When you apply plus between them, what is this? One rational, one irrational. Sum of rational and irrational number is always irrational, Q dash. Some difference, A minus root B. This is also. Product, A into root B, A root B. This is also irrational number. Division. Where B cannot be a perfect square. B cannot be a perfect square. Then only root B will be irrational number, right? So that condition you should remember always. For example, some of them taking like root 4. So root 4 is irrational number. No, root 4 is not a irrational number. Root 4 is a rational number because 4 is a perfect square. 2 square value 4. Square root cancel. Root 4 value is nothing but 2. Okay, na? So mainly rational numbers are expressing into three different ways like root 2, root 3, root 4, such type of examples for one of the examples for rational number. Next, second one, non-terminating, non-repeating decimals. Third one, transcandal irrationals like pi and e. The different types we have discussed. Please note this. This also, A is a rational, root B is irrational. Some difference, product and quotient. All are irrational numbers. Okay, no? So let us discuss about a square root. Square root of a number. Okay, no? Right, you know about the square number. What is the square number? What is the square number? Yes, if a number is multiplied by itself, a number is multiplied by itself, gives its square number. Like 5 into 5, 5 5s 25. So 25 is a square number of 5. Okay, na? Same way, inverse operation of square is square root. Inverse operation of square is square root. Okay, na? Square inverse operation, square root. Square root is nothing but whole to the power of 1 by 2. This one. Okay, na? That is a symbol for square root. Cube root, fourth root, fifth root, like that. Okay, let us go to the next. how to find the square root of a number. How to find the square root of a number? There are two methods. One is prime factorization method and second one is continued division method. Okay, na? So I hope everyone knows about the prime factorization method. So let us take the 225. What is the square root of 225? So I am using the prime factor method. 5 table, 5 4s 20, 5 5s 25. Here 3 table 15 times, 3 table 5 times, 5 table 1 time. So 225 we can express as 5 into 3 into 3 into 5. But I am asking here square root. Square root of 225 equals to square root of 5 into 3 into 3 into 5. 5 into 5, 5 square. 3 into 3, 3 square. We can write 5 into 3 whole square. Square root cancel. From these pair of 3's, 1 3 will come. From these pair of 5's, 1 5 will come. Without the root. So here 3 into 5 is 15. Therefore, square root of 225 is 15. This is the prime factorization method to identify the square root of that number. Only pairs we have to take because it is square root. In case it is cube root, we should collect only one out of 3 same such numbers. Here 2 same numbers, 3 into 3, only one number came outside. Here 5 into 5 same number, only one number came outside. So 3 into 5 is 15 is the square root of 225. Clear? Yeah. Now let us discuss the division method. For example, 1444 is there. 4-digit number, how to find the square root? Square root out of a 4-digit number by using the division method. So mainly you should remember the steps here. First step 1 is we need to separate as pairs. We need to separate as pairs from its units place digit. From its units place digit. That is the first step. Like 1-3-4 from units place digit. 4 pair of digits as a group. That is the step 1. Step 2, we need to use only the square numbers. We need to use only the square numbers. Square numbers means, yes, 1 1s are 1 is a square number, 2 2s 4, 3 3s 9, 4 4s 16, like that. Now here 14, nearest square number is 9. Next square number is 16. 16 is more than 14, right? So step 1 is we need to separate the number, separate the digits in the number as groups, two digits as a group. Next, we need to use only the square numbers, such like 2 into 2, 3 into 3, 4 into 4, 5 into 5, like that. Now here nearer square number this, 3 3s 9. So 14 minus 9, regular subtraction. Yeah. So next, the quotient should be double. That means 3 2s are 6. Third step, you need to take the same number here and here. Like if you take ones, now consider 61 ones are. If you take 2 here, 62 2s, 124. If you take 3, 63 3s, 189, like that. Okay, na? So I am taking 60. Yes, 68 eights are. 68 eights. What is the value of 68 eights are? 8 eights are 64, 6, 8 6 are 48 plus 6 54. Exactly 540. Remainder 0. Therefore 38 is the square root of 1444. Therefore square root of 1444 is 38. Okay, now this is continued division method. This is prime factorization method. Division method, first step, we need to separate pairwise digits. Two digits as a pair, we have to group it. Second, we need to take only square numbers to identify this. 3 3s 9, remainder 5, bring down the pair of digits. Next, double the quotient, it becomes 6. Now here and here you have to take same number. If you take 161 ones, 62 twos, like nearer value, nearer to 544. 68 8s exactly, 544, remainder 0. Therefore, square root of the given number is 38. Okay, na? So just try to do this problem. Try to do in like 729, try to do it in both the methods, prime factorization method and division method. So try to solve it right now and tell me. I'll give 1 minute time to you. So what is the square root of 729? 27, am I right? You identify by using prime factor method. Now let me explain continued division method. So two digits as a pair. But here single digit only 7 remains. So nearest square number. 1 1s are 1, 2 2s 4, 3 3s 9. 9 is more, so we have to take 2 2s. 2 2s are 4. 7 minus 4 is 3. Bring down the remaining part, 329. Next, double the digit 4. Now here and here we should take the same number, 47 sevens, 329. Therefore, square root of 729 is 27. Okay, na? So until then, what we have discussed? We have discussed about the irrational numbers. Irrational numbers decimal form is nothing but it is neither terminating nor repeating. Neither terminating nor repeating. Okay, na? And second one, they are in the form of square root of m, where m is not a perfect square. And third one is pi and e, transcandle irrational numbers. And irrational numbers are represented with the letter q dash. And then after we have discussed about the properties. Like if you take a rational number and irrational number, between them if you apply in arithmetical operation, the result, the answer is obviously irrational numbers. Okay, na? Next, sum of any two irrational numbers need not be irrational. Product of two irrational numbers need not be irrational. Sometimes there is a chance of becoming a rational number also. Okay, na? Then square root, what is square number? Then inverse operation of square is square root. Then after we have discussed about how to find the square root by using prime factor method as well as division method. Okay, na? Yeah. Clear, children? Right. So once you try to solve the problems from exercise, and before going to these exercise problems, 4 or 5 properties are there for square number, square root. Properties for square root, let us see quickly. So root over a into root over b. Two irrational numbers, root a, root b. Square root of root a, square root of root b. That can be root over a into b. Multiplication we can apply between the two irrational numbers. Next, root a divided by root b. Yes, it is also possible. Root over a by b. Or root over a by b we can write as root a and root b separately. Or root over a into b we can write separately. Root a into root b. Root can be applied both of them separately. But here, root a plus root b is not equal to root over a plus b. Addition is not applicable here. Root a plus root b is not equal to a plus b. Root a into root b can be root over a into b. Root a divided by root b can be root over a by b. But root a plus root b cannot be root over a plus b. Same way, root a minus root b is not equal to root over a minus b. For addition and subtraction, we cannot apply the square numbers directly, square root directly like this. But multiplication and division we can apply directly, or we can separate them. Okay, no? Yeah. So just revise this. That's it for today, children. Have a nice day.